Cool. Good morning. Today I'll be talking about population-based algorithms and their various optimization techniques and abilities, as well as how you can apply some of them to robotics. Population-based algorithms are a subset of algorithms that typically fall under the nature-inspired algorithms group. And as the name of the group suggests, all of the algorithms that fall in this group have an integral part of their optimization centered around having a population doing the optimization. These algorithms typically draw some sort of inspiration from the world around us, such as the genetic algorithm drawing inspiration from aspects of natural selection and survival of the fittest, to the original inspiration of the particle swarm optimization, drawing from the social interdependence between a flock of birds or a school of fish. Although variations of the particle swarm optimization can draw inspiration from interesting things in the world, such as the headless chicken particle swarm optimization, which despite interesting inspirations does perform statistically better than proportion of its predecessors. But what are the advantages of using a population-based algorithm? One big group of this is that you can typically find an optimization algorithm for many problems that you can face, from stochastic to graphical to combinatorial and continuous. Typical benefits of this is due to the fact that when you're using a population, you can easily search across a large space of your search space, giving you a better ability to find minima or maxima depending on what you're looking for. They have a good ability to be very flexible and be able to handle things such as complexities. Due to them using a population and a lot of the calculations being independent of one another, they're well suited for parallelism, allowing you to reach your finishing points much faster. They are incredibly customizable and typically incredibly simple to implement. A good example of this is the original particle swarm optimization algorithm. To set up a particle swarm optimization, you have to decide on the number of particles in your swarm and initialize them randomly across your search space. Then you find across each of the particles which one best suits your current optimization function. Then you update all of the particles' velocities, which is initially set to some random value, typically 0, with this formula, where it's some weighted addition between the current velocity, the difference between the current position and the particle's personal best position, and some random proportion of the difference between the current position and the global best position. The variables W, C, and K are predetermined before you start your algorithm, and the variables R1 and R2 are random. Then you update each particle's position using where it's just the new position is the previous position plus the particle's velocity. Then you must find all of the new personal bests of the particles and the new global best, and you just continue this algorithm until you reach some stopping condition that you found, that you predetermine. One algorithm that suits robotics typically well is the ant colony optimization technique. This optimization algorithm typically is used to find paths and various other optimization techniques through a graph. The most obvious application of an ant colony optimization to robotics is pathfinding, helping robots reach their points through their search space much more easily. The second is task allocation. The ant colony optimization can take into account the various tasks, what they require, a robot's ability to perform the task, and priority of each task to then allocate which robots need to execute which tasks so that each task can get done as efficiently as possible with the best means possible. And the last of the big applications of that is exploration and foraging. Ant colony optimization can use this to show through a search space that the robots need to look for resources that they need to use. You can use the pheromone production that ant colony optimization produces to show which parts of your search space each robot has looked for, and a higher pheromone concentration can show where the resources are that you're looking for. In conclusion, population-based algorithms are typically very easy to implement, and you can find an algorithm to apply to any sort of optimization technique that you need, as well as they can easily be applied into interesting fields such as robotics.